Yeah, today we'll go into regression and reports. Regression deals with a bit of statistics, and I call it the introductory part to machine learning in general. But these concepts will be explained in simple terms. And after that, we go to Quarto. Then we learn about Markdown, which is the right with Quarto. So after that, we'll learn how to we'll learn a bit about reproducible documents, and maybe we'll touch on Shiny, but I'm not sure about that. So now let's dive into our studio. This is the script that we used for yesterday. It's already available on the GitHub repository. So I'll create a new script. Maybe not. Yeah, I'll create a new script as a new project. Let's just let that load. There's something I would like to show you guys before we start properly. Create a new script. So this is the outline we have for today. The same as yesterday, Ctrl-Shift-C, we just to simply comment out all this. So the first thing I want to do before we move in properly is to show you how powerful background jobs can be. I have some scripts in this file. We have package install scripts and quick simulation scripts. And if I open this, what this does is it simply install packages. Yeah, it installs some from from GitHub, and also it sets the store where I want to download it, which is crap. So it's just a simple script to install packages. Then after that, I want to remove all the variables I've created or objects I've created here. Then the other script is a quick simulation script to just flip coin. Now, we're about to do something that is quite powerful. It's R, because we can continue whatever we want to do now, and we'll run these background jobs. So what I'll do is I'll just start background jobs, I'll browse, and I will locate this file, package install. And once I open it and start it, and once I start it, you see that this is loading. Then I can continue whatever I want to do. If there's any error, it's going to tell me if there's an error. Yeah, so today we'll start with linear regression. And before we can do anything regression, we do need the data. So we are going to use one of the data that we have in the previous lesson. Let me see. I think the math score data, it's a nice data. Yeah, so this one would be nice to work with. Yeah, so I'll copy that and paste it here. Math score. Let's always remember to load our packages. So we'll need the tidyverse package. That's one thing. And what else? We need the read Excel, since we want to read an Excel file here. And what else? I think we can just use this two for now. If I want, I can also read Broom. Broom is a name of the package that can give nice output for whatever I want to do with linear regression. Yeah, so this is what we'll be doing. Now, loading all these will not interfere with whatever is happening here. So I'll just load it, and you see it works fine. But also, let's go back to background jobs. We see that it has succeeded. I can keep working while this continues to work. But since that's completed, I can simply just start another job. And this can be very, very useful when you have like a task that requires time to do. But you know you have to do other things. For example, let me load a fairly heavy task. It's not really that heavy. And this is a quick simulation. This one is just to simulate diagram in general. Then once it's done with that, it exports the results into a table. So it is done with this, and this is the diagram here. Once it's done, it should save it as well. Save results.rds. That's it. So yeah, I'll close this too. And it seems it's done already. So this is the result here, 0.49988. 228. You might not know how this is powerful, but once we get accustomed to working with R, we see that some of the times there are some tasks that take longer. All those tasks, it's best for us to just put them in a script and make them run in the background so they will not interfere with any other thing I want to do. So that's what I want to show you for now. Now, moving on to linear regression. Linear regression simply means working with variables that have some level of interdependence. Yeah. For example, now we have this math score, which is a nice data which we worked with yesterday. But beyond that, I think we did some transformation with math score. So I'll just lift those. We have grades, grade total score. This. Okay. Math score. I'm trying to see which one we can work with. Okay, not this. You can simply just do everything again and to be a good refresher for what we did yesterday. So math score. Now I can print math score so we see what we have. Anytime we import any data, the first thing to do is to always preview the data. We cannot overemphasize how good this is. You need to preview the data, and then after that, check the structure of your data to see if it's in the form that you like or it's having the variables that you expect. Let me close this part. Now it's already shown us the different data types that we are having for each columns here, for each variable, character, numeric, and those are the main things that we have. Then also we can check a quick summary of our data, and we have math score here. We just use the summary function, and also press enter to give us a nice overview of our data, a good summary of our data. Now, it shows us that school is a character data type and has given us the length, 395 observations. Then we have age, minimum is 15, maximum is 22. So the oldest student is around 22 years old, while the youngest is around 15. Sex is also character. Then we have address, and this is what also a character. We have medu, and now we do not know the meaning of medu. We also have fedu, we do not know the meaning of fedu, because this as well, since it is 0 and 4, this as well could be like numbers that represent actual things. Yeah, hello guys. Sorry about that. My router restarted suddenly. I think it was an upgrade. So that's why I just got off suddenly. I just noticed. So give me a moment. I will connect and I'll share my screen again. Okay. Can you see my screen? I think it should be up now. Yeah. Please, just tell me. Oh. Olawale, you're saying something.
Yes, we can see your screen.
Okay, that's good. Yeah. I was giving an explanation as to what this is. Farm row, medu, 0 to 4, 0 to 4. It's something that can just easily lead to mistake when analyzing data. Yeah, so one thing to do is always to check a data dictionary if you have any. Unfortunately for this, there's a data dictionary. So I'll just look for medu, MEDU, and this is medu here. And now we can see that it means mother's education. Right? Fedu means what? Father's education. And this now is pointing to see that why it is written as numeric is actually a factor. That means a categorical data. This is saying that 0 means the mother has no education, 1 means we only have primary education, 2 means 52, and so on and so forth like that. So we just need to be careful generally when interpreting our data. Yeah, and using summary, you just give us a good breakdown of what these things they mean. And we can see now that okay, if the third quarter, the max and the mean, in a way, this is not like a normal distribution. It is not random number. We can't also say that it is uniform, a uniform distribution. What it points towards is that the numbers there are used to represent something. And we can see it in other numbers too. For example, let's see. Study time too could also mean the same because it looks weird the way it is. Okay, now let's see study time. It says numeric. 1 means what? Less than 2 hours. So it's not actual time, but range of time. So it's also a categorical data like that. I don't know if you understand what categorical data are. If we don't understand, I can give a context to what they are. If I have no question, I will assume that we all understand what categorical data are, and we can move on. Anyone with question? You understand what they are? Okay, so we are good. Now, there are those different parts of this data, but we do not need to be interested in everything. Let's just take only very few of these. This now G1 to G3, that is the total score, and it's in 20s. But here we can see that the maths person scored 19, and here the person scored the perfect score. So the combination of all this will give us 60, and we did that yesterday. So we'll just repeat it today. So what I'll do is I'll firstly just select variables or columns that will work with. So I'll select, let me get the names of math score. So I'll select school. We'll see if the school influences the student performance, their gender, the age, the family size. Does that really matter? We do not know. Generally, we would want to test everything. I also choose from G1 to G3. I think that is important. That is where the score is. Then we have something about internet. Let's check internet, what internet means. Internet. Okay, yes. Do they have access to internet? Yes or no? Okay, yes. Let's just take that. Take internet. And we just leave it at this. We do not want to complicate it too much. So this is the data we'll be working with moving forward. And I'll call this choice score. And now with choice score, we can start to do some data wrangling. The first thing we want to do is get the total score of students. And with that, we use mutate as we learned yesterday. And we give the name of the column, which is total score in this case. Then we perform whatever operation we want. And in this case, we want to just add everything. That's for the score G1, G2, and G3. Then also we let me see, we have sex, we have school, these two, their characters, we have internet, and this internet actually should be a Boolean since it is no yes or true or false. So what I'm going to do is I'm going to introduce something new. Firstly, I'm going to use case when of or if else statements, either of the two works. I'll use if else statements. So if internet is equals to no, I want my data to be false. Else, I want it to be true. You can just run this and see what we have. Now we see that the data type has changed towards logical from what we had before. We had character before, but now it's logical. So what is left is for me to change this to school and sex to factor data type. And that's because whenever I want to model or perform regression, regression does not work with character, as characters are just general data type. They take anything, but factors in some ways they are represented as numbers underneath. And I can show us an example now. So what I will do is I'll take this and I'll say across where is the character. I want to change them to factor like that. In a moment, I want to change them to factor. And now we have FCT, meaning they've been changed to factor. But that's not all. Since we have total score, it would be nice to have percentage. So it's in 100. Yeah, it's in 100 rather than over 60. And for that percent score, we'll simply divide total score over 60, which is the total, then multiply by 100. And we are good. And once we do that, we have, okay, this is not showing everything. And now we have what percent score like this. So we can save this if we choose. I'll save this as choice score. And I promise to show us something that factors are what represented as numbers underneath. First thing we can do is we just take choice score and we select school, for example. And here I'm using the dollar sign. The dollar sign is used to what? Ensure we take a subset. And on pressing the dollar sign, if I press tab, it's going to show me all the columns that are available within that object. And here I'll choose school. If I print it, it's just showing MS and GP. Then we have something. Right here, we are saying what? Levels. Levels means that what? That this is no longer a character. But a factor, this is one way that we know if an object is a categorical data or just random characters or strings. So still taking this, I can make them unique. Unique will just return the distinct values. And here we have GP and MS. And in addition to that, I can nest it again to just get the numbers, okay? As dot numeric. And with as dot numeric, I'll convert them to numbers. And you see that it works fine. And the reason why this works fine is because this is already a factor. You can take math score, for example, and math score is also having school. If I get the unique, okay, if I get the unique value of math score school, we have GP and MS like we did before. You see the output here. You see it's different from this. This is having the quotation mark, which shows it's a character. But this is showing that what it's a factor. As you can also see that it's adding levels. Then if I still move on with this, then I try to change it to number with as dot numeric. Then you see that we have an error. That what NAs. I said that we have 3 types of logical. We have true, we have false, and we don't know, which is represented by what? NAs. So that's what we have that is returned here. So moving forward, I don't know if you have any question before I proceed. Because I know I kind of covered a lot of concepts that still relates to data type here. Okay, any question? Okay, if there are none, we can move forward. Now we have choice score in a good form. And since the main thing we want to do now is just work on regression. So what I'm going to do is we'll start with the simplest, this ordinary least square. This should be OLS. Yeah, ordinary least square, and it's just a regression model with one dependence variable and one independence variable. That's all it means. And what dependence means is that it's what we are trying to find is something that we derive or something else. For example, now sex, gender is gender. Do you use internet? Yes or no? How old are you? This is age. So there's nothing that we can do to influence age. Of course, if we want to kill the person, which is we should just put a stop to that. But score now, this total score is something that can be derived. Then the percentage score is also something that can be derived. So something we can do here is we can try to test to see if the age of the student influences their score. That's one thing we can do. We just check if the age of the students influences their score. And if it does, that would be a very good finding. Yeah, excuse me, please. Yeah. So to carry out a regression analysis, we use the function ln. Yeah. And we can check the documentation of ln by using this question mark then lm. Of course, you see fitting linear models. And that's it. So for this, the first thing we have to do is we have to determine what our dependence variable is, and also what the independent variable is. It's just one-to-one in this case, meaning one independent variable. So we need to just determine what the two are. And the dependent variable here is percent score, while the independent variable here is what? Age. And the formula for this is usually yx, like this. That's just it, meaning that percent score, whatever percent score is dependent on what? On the age, which is what we want to find. We want to see if the age in some ways influences the score of students. So what we'll do now is replace this y, which is percent score here. Then we'll replace x, which is age. Then we include our data, and data is equals to the choice score. And now once we enter this, you see that we have this. Now this does not really look nice. It's just showing us intercept and it's showing us age. And of course, we already have an insight to what this means. Now let's just save this. We can save this. I'll save this as math score model. The model 1, since we still do multiple. Let me break this down. Percent, age, data, choice, yes, like this. So we have math score model. Before that, what we run is this simple thing. And what this means is what? Let's just interpret this. ln is telling us the formula, and the formula is what? Percent score is dependent on what? On age, Our data, of course, is choice. Then it's showing us the intercept. What intercept means is what? The value of the student score when the age is 0. That's what it means. When the age is 0, the percent score of the students. And here, if you see here, it said when we have an increase or decrease in this, and this is definitely a decrease. That means a decrease in age is what we add a unit in this. So older people, in a way, are not smarter. That's what this model is saying. You can check because this is not enough to give a conclusion. So we can use summary to check. We can use summarize or summary to check the model and get further explanation. Let's check this now. Now we have the minimum, the median, max. Then we also have this. This is something we usually see a lot in publications and in papers. And we used to see this different asterisks, showing if there's a significant difference. Then here we also have the error, standard error, the estimates. These are the things that we use to predict the model. And it's the same thing which we have here. And it's showing that a decrease in age will increase the score by a unit. That's what it means. Yeah. Now let's check here. We have residual standard error. That's 18.34 on what? On 393 degrees of freedom. Then we have the multiple out squared. Now all this seems like jargon, but they actually advise us to see if this is enough to consider this as good. Now the out squared means that do we have enough age, or is age enough to actually explain the percent score? And this is showing what? 0.018. That's around 1.8%. And that is very low. So it is not doing enough to explain the percent score, meaning age, why there's significant difference as we have here, showed by this asterisk, is still not enough. So that is just a simple linear regression. You can try something else to see if it will improve the model. And that will take us to what? Multiple linear regression. And for that, I'll just take this, I'll copy it, and I'll paste it here. I'll change the score model to 2 now, since we are using a different model. And we have percent score is a function of age. But now I want to add another variable. Let's check our data again. We have choice score. And now we can see if we can add the gender to see if it actually influences it. So to add the gender, we can use plus, then we have the sex like this. So if I run this, we see what we have. Now we see minus 1.909. And we see that we have sex M. The sex M that we have here is only accounting for the male. It's not showing the female. So there's something we can do to just ensure that everything is being accounted for and nothing is left out. And now we see we have sex F and sex N. I don't know if we understand what is happening here. For this, the female has just been taken as a part of the intercept when all the values are 0, when age is 0, when sex is 0, when the male, the sex is male, we have around 3.57. That's what it means. But now, to actually know the score and account for both female and male, I use -1. And with -1, there will be no intercept. As you can see, that there are no intercepts yet. So what I'll do now is I'll delete this and I'll run as max score. We just sex as it is. Then I can check the summary here and see what we have. I will see that age also is significantly different. The intercept, of course, but look at age. The significance is very low. The significance is very low. Michael is asking something in the chat. I do not understand. Michael, are you asking anything? I see that the chat is up and your name is up. Is Michael there? Okay. Let's move on. Now, let me interpret this. What this means is what? A unit increase in age, it reduces the score by what? -1.90. As I said before, the older they get, the less smarter they are. That's what this model is saying. And now this is saying that what? For male, you have a 3.5 increase in score. This will make me create the third one. And the third one, we now include the female and we remove the intercept. Let's check it. Now, summary math score. Model 3, this way. And now we see age is minus 1.90. You see that it's still the same as before. So as they increase in age, the lower their score is. But for the female, we see it's 3.56. That means when everything is 0, the female score around what? It's 3.5696. If we check this, we see that it's exactly what we have in the intercept. And for the male, they have 87.1690. And this means that what? According to this model, male is scoring about 3.5 more than female by default. I hope you do understand that. 3.59 more than females by default. That's what this model is saying. But now we've seen regression, then the question is, okay, what can we use this for? Or can this be used in true life case? And yes, that's true. It can be used when we want to predict the score. And I do not have a sample data for that, but the function for that is we use predict. And we predict, what we do is we simply include the model. In this case, you can say math score 3. Then after that, we need to include the data that we want to predict on, which I have none at this moment. But I can try to create one, choice score, and slice. I just slice sample. And with this, I just take randomly. I take like 30, 40 randomly. So now we have 40 data like this, taken at random. But for this, we need to remove the percent score, which is what we want to predict. So still with this, I will select just sex, which we need. I'll select age, and we are good. So we have only sex and age because our model used only age and sex. So I'll call this new data this way. So once I put new data here, we can try to predict. And this is it. It's giving us a score already. But this does not make sense. So the way we use it oftentimes, we take the new data, then we mutate. Then in what we've mutated, we call it what? Percent score. Since this new data by default that we have here is having no percent score. So we create the percent score column for it, percent score. Then we take this, which is the predict right here, cut it and put it here. Then once I do that, you see the score that it gives us. It gives us 53, 54. It has already predicted the score of the students that way. And this score now is a function of both the age and the female. So this is what regression is used for. And it is used a lot in the field. You just get only minimum data. Like, for example, my field is forestry now. Oftentimes, one of the data that is very difficult to measure is the height of trees. The height of trees is very difficult to measure. So oftentimes, height is always taken as a function of how wide the tree is. That's the diameter, or how fat it is, the diameter of the tree. So what they do is they just measure like maybe 100 trees. They get the accurate height of that. After that, they'll measure the rest. They'll just measure only their diameter of the rest, and they'll leave out the height because they already have enough sample size. So these are things that are interesting, and things that will be covered actually in the bootcamp, because this is what actually differentiates what makes analysts. Once you can provide solution, once you can give predictions, once you can tell relationship, and then you can say that I've noticed that during this period of time, people are not buying our product. Why? So it's usually regression that makes us answer questions like that. Because now, if we check this, we can see, let me bring it up again. Summary model, what is it? Math score model 3. And see with math score model 3, it's saying that what age is what? The older they get, the lower their score. And by default, female is what? 83.5. And for male, 87. So this model sees male as smarter. If we check model 1, it's just only telling us that what age is a factor, but also is not explaining enough. 0.18. Let's check this order. This one is giving enough explanation. This is 89%, which is very good compared to what? 1.8%. This is 0.018. That's 1.8. And this is 0.89. It is already close to 1, which is 89.6%. So this model is better than the previous one. So that's just this. I don't know if you have any question before we move to Quarto. Any question? And there might be confusion somewhere. Please, if you are confused in any way, you can ask me. So I provide answers. Questions? Okay. No questions. Yeah. Next, we are going to move to Quarto. Yesterday, I showed us some things, a blog post presenting our work, and I spent a few minutes showing how to present our work or showing the destination of whatever we are doing, where it should go to. One way or the other, whatever work we do, we need to present it. And Quarto would help us do that well. So I'm going to save this first. I'll call this reg script, which is regression scripts, and I'll save. Yeah. So to create a Quarto document, the first thing we have to do is click on File. Of course, we can start a new project, but instead, we want to create a new Quarto document. And now I'll give this a name. I'll say, since it's a school data we are working on now, math, I'll say students performance in Portugal. High school student performance in Portugal. The author is just faithfully Olamide Adu. And this is where we have some options. I can either choose to save this as HTML, that means in web format, or as a PDF, or in Microsoft Word format. So for now, I'll just simply save as HTML, no, PDF. Then I'll create. Now, one thing to do before you are able to use Quarto is you need to come to your terminal. You need to install something. It's called Tiny Text. So I think I have Tiny Text. You just click Quarto, you type in Quarto, install Tiny Text. And once you type this, it's going to install what will make this render. That's what it's called, render. This might take a few moments, but it won't disturb whatever we are doing. And it's something that I just need to install once. So while this progresses, I will continue to what we can do. And yes, let's look at this now. This is the title that I imputed earlier. High school student performance in Portugal, my name, then the format I choose, PDF. I can say I want HTML instead of PDF. And then we have this right here, Quarto, which is documents that they've inserted for us to begin with. But now I'm going to delete everything. In a way, we see this looks like Microsoft Word. I'm going to expand this part so we can see better. I'll just check here. Okay, this is still installing. Yeah, so usually in our documents for people involved in research or people that wants to go to school or further their education, or people that are already in school that are writing their thesis, we have different sections of paper. What we do, we have the introduction, then after the introduction, some people, they have literature review later, they have methodology, then after methodology, they have results, then some have discussion, like that. That's for people in school. But for people that actually give technical reports, maybe to their boss as an analyst, and they want to give it to an head or something, what they do is what they have like introduction, and this introduction oftentimes includes things like motivation and things like that. Then also they show the results and they give an explanation of what they are trying to get, and lastly they give a recommendation. Some people also include recommendation, but the gist I'm just trying to give is, this is the gist of it all. We have structures in paper, and this introduction usually is like usually bold as well as literature. Then it's going to have little text underneath. We can do this. This is something we do with Microsoft Word, and we can also do this using Quarto. So to begin with, I want to create a document just following the academic structure for them. So I will take this and I'll set header 1, and we can see that it's already big. Then I'll type in what I want to type, introduction. Once I press enter, I'll see that this I've turned to normal. Then I can keep on typing like that. This study is to investigate the performance of high school students into high school students of 2 schools in Portugal. Yeah, so that's my introduction. Then next, I can go to something like a subheading. Now I might say I want to do problem statements, and I type whatever problem. We notice that students are not performing well. Then I move to the next thing, might be data collection or something like that. So data, for example, and for this, I could say that the data was collected from UCI Machine Learning Archive. Now, this is simple text and everything. And the question is, why not just use Microsoft Word? That's the main question. Why go through all this when you can use Microsoft Word? Where this differ is you can insert your code here. If you check the title, what we have here is called what? Dynamic data enabled reproducible documents. That means whoever you send this Quarto documents to, as long as they have a Quarto enabled device and or software, maybe like Python, or they have Quarto installed also, or like R or Julia, they can also reproduce your work. But oftentimes it depends on the language that you'll be using. Yeah, so now moving, one thing I'm going to do is I'm going to insert code to this. And to insert code, you see that we have this code. No, insert, then we say executable cell R1. Then this is called a code chunk. So this has inserted what? A code chunk. Now I always prefer to use shortcuts, and generally I do not like scrolling through with my mouse pointer every time looking for what to insert. But the thing is, we have more to do than this. And of course, why this view is very comfortable for a lot of people. And I advise people that are comfortable with it to use it. Just explore with the options that we have here, and you're good. If you want to insert table, that's if you want to create a table or insert any other thing, you can simply pick it from here. But for this masterclass, we're not going to use the visual editor. Instead, we'll be using the source editor. And that's because the source editor is powerful too, similar to the visual editor. But for me, I just have everything under my control without needing to point and click. So I'm going to delete the editor here. Then I can add a theme if I like. For example, I can say I want cerulean as theme. Let me check if this is done. Okay, it's almost done. Yeah, I can add cerulean as theme. Then I'll delete this, all this for now. And I'll just simply render. Let me save this. I'll save this as Portugal high school study and save. So now I can render. And once we render, we have a preview. What rendering does is it's trying to create the document so we can see what we've done so far. So Portugal should be capital P. And this is taking a while. So while it's taking its time to render this, I can as well put in more code here. Now I've inserted a code right here, a code chunk. The shortcut to do that is Control Alt I. But alternatively, you could use this plus here to insert a new code chunk. So usually this interface is usually a home of its own. It's isolated from all that you have right here from this script. Okay, I think it has loaded now and it's about to show me what it has rendered. It's still loading. I'll just go back while it's loading up. Let me minimize it. I'll minimize this too. And yeah, you see what has been produced. I have the author name. I have the name of the school. And okay, I'll take this here. And let me just split the screen. Yeah, so this is better. So I can change the theme too, because there are different themes. Then I render again. To render, you can use the render button or you use the shortcut Control Alt K. And now we'll see that this has changed, because once it's done rendering, we see that this has changed now from blue to this. There are different types of themes. You have to check the documentation. That's Quarto themes. Yes. And if you check Quarto themes, you see all the themes that are available. You just click on it and you can choose whatever you want. This is the one I used before, cerulean. Then I chose darkly or what? Okay, this should be darkly. Then there's darkly. So whatever you choose is going to give an output. But I do not like the way this is always taking me to a browser. I would like to view it here rather than see it in a browser. And there's a way to change that. I just click on this button here. I'll say preview in viewer pane. We have this pane here, which can also show us the results. That way, I do not need to leave our studio. And once I render a game, I'll see that the results will come up here on the viewer pane. Then after that is taken care of already, you have to go to the basics of Markdown. And that's because the source editor uses Markdown. I don't know people that use WhatsApp. We've seen some of the times we have texts that are bold on WhatsApp. Let me just search it up. Bold texts on WhatsApp. And it's not just bold, we have italicized texts on WhatsApp also. And that's because what they are using in a way is what? Is some form of Markdown. Yeah, they say that the text appear bold. That means you use what? Asterisks, like this. So Markdown is a bit different, but it's also follow a similar convention as this. So for example now, if I want to make Portugal bold, what I do is I use asterisks, 2 asterisks to make Portugal bold. And once I render again, it's going to show me what as the changes that I have. Let me take this off. And now we have the hash symbol here. The hash is used to tell us, okay, if this is an heading. So 1 hash means what? Heading 1, 2 hash, heading 2. That's the level of the data like that. And 3 hash like this, it means heading 3. So to go to the more interesting parts, let's just go to the code. And that's where we see the magic of this. Yeah, so Portugal is what? Is bold already. Now going to the code, the first thing I want to do is what? I want to import tidyverse. And all that we've learned in the previous day, I'm going to just bring everything here. I've given my problem statement, which is not a class of problem statements. I'm sure I don't even understand this problem itself, HSV. I do not know the problem, but I'll try to get something out of this. Now, for the data, we can import. We also need to import with Excel. Yeah. So once I click on this play button, it's going to import the 2 of them like that. So we have our math score, and the math score we use with Excel as before. Okay, and we locate our data. Where is the data? The data is, okay, this math score, student performance, and student maths. Okay, and here we have our data. So I'm going to preview our data first. So previewing the data. And for that, I'll use ed math score. And that's okay. To also see the other part of the data, which is the end, you can use stay like this. So moving on, I can say I want to visualize the data. All that I'm typing now, it starts to make sense soon. So we take math score, for example, math score. I will say we want to see the number of females that we have in the scope. And I will use ggplots too, ggplots, and take AS, then we have sex, plus bar, and this will give us the number of female. Okay, now we've added a visualization. We've seen how this looks like if it's an HTML file, a web document. I can change this to PDF. That's the file format. I always prefer PDF formats. Then once I render this, you see that the viewer will also present it in a different way. It's no longer a web document, but instead it's a PDF file. If we check file, we also see the changes. that it is making. You see the number of files it has created, the R Markdown file, the .html file, and the folder also. And this is because we saved the format as HTML before. But now we are saving it as what? PDF. Okay, I'll wait for this. Just wait for this to run. And once this is done, let me check if this is done. Okay, this is done. Yeah, so we should be able to work without problem. Yeah, and it's going to show us the PDF file. And here we have the PDF file. If we check files, we'll see the PDF, Portugal High School Study.pdf. So this is one nice way to always present your work. You can either save it on PDF and save it in a place, or use the HTML and upload it online. So it's a website that people can view and read what you've done. Now, this is something that we did not see before. All this attaching the code, this thing, it is something that we normally see in the console. But I will also teach us how to remove something like this. Then we have the problem statement, and this is a nice problem. Then we have data, and I've already read in this code like this. If you notice, it's showing the code and it's showing the text. So this is a good way to show what you want to do. This is a good way to show what you can do with a language. Any language is a good way to show what you can do. But aside from that, some of the time, you do not want to show this, especially if it's in a publication or if it's a report. They are not interested in the code. They are just interested in the findings. We're also going to learn how to remove that. Now, I've released it. I've also produced a table. The table is not the finest of table. I can make it better. And this is also another table. It just looks like the regular printout that we have, and it's not also nice. Then we have the math score here. And look at the visualization we just created. See that it's exactly as expected. Now, where we are using Quarto shines, firstly, is if they need alteration. If they need alteration, now you do not need to go to Microsoft Excel or whatever other software you are using and make that changes, then copy and paste that in your Word document again. Instead, you can do it here. For example, if they say, oh, we do not want sex any longer, we are interested in something else. Let's see, let's check. Let me check what we have for the column names for math score. We have health, we have G3, okay, we have school, we have age, family size. So if they say that we are no longer interested in the sex, instead, what we want to see is, we want to see the school. We simply come here and change this to school. And once we run this, once we run this, the document is going to change automatically. Meaning that what? We do not need to make changes in multiple places, which used to lead to what? High likelihood of making mistakes and error. But instead, we only need to make change in one place, which is our Quarto document. Then we can render and to just give us the output which we expect. Yeah, so now I'm going to just move on into making this a bit more presentable. For example, I do not want to see this library here. So what I will do is, the first thing I will do is, I will turn off some things. And to turn off things, you use the pound and the bar. And what I want to do is, I want to remove the message. This is a message. I want to remove the message. Not only that, I also want to remove any warnings that we have. Then I do not want to include this block at all in the code. I do not want it to appear. So I also do this, echo false, and I will render my script again, my Quarto document again. And once I do that, you'll see that these parts that we do not need, they're gone. Okay. And let's see. Now they're gone. So this is one of the ways we control all those aspects of our documents we either want to show or not show. Now we have math score that is like a big table, but we can present this in a better way. One way to go about that, for example, let me just remove the tail since we do not need it. One way to go about that is to reduce the number of outputs which you have. Maybe just reduce the size right here, since this is a PDF document and not a web document. So I'll just select the first 6 columns. So the first 6 columns. Then I will use another package. Package is called needs R. Then I will use cable. Cable is part of needs R. So there are also other packages that we can use to make the tables that we have look better. We have GT. Let me write them down. Maybe I write them in the script. Yes. So table packages for Quarto. We have needs R. We have needs R. We have GT. We have GT extras. Then also we have GT extras. We have format tables, FMRT tables, and different other packages. If we search Google, we see more packages that we can use. We also have React table and DT, among others. Now let's look at the output. We see that the way the table is presented is different from what we had before. It's printed everything, and of course you do not want this. So let me use Edge to reduce the output. So it will limit it to 6. To limit the output to 6. Okay, let me render. Okay, let me render this. Yeah, I don't know if you have any question. I know any question because I know I've done a lot. I've introduced a new concept, which is Quarto, and also in a way I've given us only a little insights into Markdown. Of course, the Markdown I did not tell us everything. I only told us about adding the heading, making text bold. You can make a text italicized just by using one asterisk. But aside from that, you can also add images. For example, instead of this problem statement here, I will use an image to explain the problem. And here, if you see, I have like symbols and added here. So to add image, what we do is we use the exclamation mark, then the square brackets, then the parentheses. So you are going to put the alt text or the name of caption of the image in this part. That's the square brackets. I can say high school student here. Then the image, now I can go online. I'll go to Pexels and look for an image that we can use. I'll use that as an example. So I'll say high school students. And whatever results Pexels give us, I'll just only copy the link, which is interesting. I do not need to download it. I only need to copy the link. So we take these guys, then copy image link. Then now I can minimize this. Then I'll paste the link here. Pasting the link already, we can see that it's already showing the image. So this is how we had images to our documents. We use the exclamation mark, we use the square bracket, then followed by parentheses. The link or the source to the image will be in the parentheses. Then the alt text or the caption will be in the square bracket. But aside from that, we can also add links. For example, if you want to reference a website, reference another source, or just, for example, I can include the link of EU Study Assist right here. I'll give www.eustudyassist.com. And once I render this, we'll see that this will not show, only this part will show. But on clicking on this, it will take me directly to this website. Yeah, so that's how powerful this can be. So any question from anyone? Any question? Are we understanding the concepts? Okay, and we have the results now. This is still loading. This is problem statement. This is an unusually big image. And look at this, high school students, and see that there's an issue here. There are always ways to edit this to ensure that it is formatted properly. But I bet you learn how to use this. You see, doing your work is very, very easy. And giving timely report also becomes easier. And that's because you are not lifting documents from one place to another. Instead, you're just doing it in one place and you're saving it in different formats. Where is the link? Now, this is the link that I added. And you see that right here, it's just this that is showing. So that's how it works. And this is also Markdown. But what about if you want to reference papers? Well, those are in academia. You can also do that. But for that, you need to create a bib file, which is something that will not be covering yet. But in the bootcamp, we're going to cover that. Now, let's just do a bit more visualization to show how good this Quarto is. Now, we've done a simple thing here. We can create more and do a better visualization. Right here, we can say the number of individuals in the school is presented below. Why this might be nice, it is not the right way to reference images, tables, or any other thing. Oftentimes, we always reference them with figure 1, figure 2, table 1, table 2. We're also going to learn how to do that. Now, let me just create a new visual, score, take ggplot. Then now we take the school, take the gender, which is sex. We make the sex the color of the field. Then we had Jumba. Then in addition to that, we want to fill there's a package that I want to add, which is very good for visualization. That is the GG Teams. It's very good. Yeah. Yeah, mine. Yeah, okay. And just bring this up. So scale. Let's go to GG Teams. I want to take one from scale, fill, Canva. Okay, scale, fill, Canva. Run. This should run. Now what I want to do is change the position. Position equals to Dodge. And I'm not sure I like Canva. Let's use colorblind. Okay, it's giving a warning. Colorblind was duplicated. Okay, since I do not want to see that warning, I'll just turn the warning off. Warning equals to false. I don't want to see any warning. Now we have this, and we want to remove the the legend. So that's legend position.legend. We make it none. The other thing we want to, okay, this is team, not teams. The other thing we want to do is legend.position. The other thing we want to do is we want to remove school. Yep. So for school, for that we say axis.title.x equals to element blank. The other thing that I want to do is we can add a theme to make it beautiful. So we have team, GG Teams is having some nice theme. Then we had labels but we had title only. I'll say number of individuals in schools according to gender. Okay, now we need the legend because we've removed that. So let's leave the legend. And now we have this. Okay, this is not a nice thing. Let's try this. We can always choose whatever theme we want, as long as it works with us. We can change the base size, make this 10 or 8. Okay, this is better. And we can decide to change this text here if we want. I usually prefer to do it somewhere up here. I simply mutate, then I show a pipe. No. I show a pipe. So I want to mutate the school, change them to factor. And now I will go to the data dictionary. Okay, this is it here. And that's because somewhere the school names is here. Yeah, we have the school names here. Gabriel Pereira and Musinho da Silveira. Those are the names of the school. I'll simply paste this here. Then I'll say levels equals to, they have GP and MS. They also have labels. I have to include school here, not to get an error. Then labels equals to this right here. And the other one, this right here. Okay. We can simply check first, see if it works as expected. Okay. This is the results. So it works as expected here. So once I run this, we have Gabriel Pereira and Musinho da Silva. I can decide to make these two, I can decide to make them bold. Let me see, we have axis dot text dot x. And we have element text. And we want the family, we want the face to be bold. The family is used to change the text style, and we can see that this is bold. We can also change this, change Y back to type 2. If you notice, I'm just hopping from one place to another, and that's because I've written my code in such a way that when I see that there are changes that need to be made at any point, maybe parts that I'm not satisfied with, I can easily go to a part and just add whatever element or remove whatever element. And that's what happens when plain codes are written. They're able to make changes, also spot error easily. So I'll change this to frequency. Then I want to change this from sex to gender. So field equals gender, like this. That's it. We can also do something, take something from this, our scripts. We have our math score model. So we can just use one of the model. Then we'll see how we can print them normally in such a way that they will have a nice print. So for this, I will add this here. Now we are not using choice score again. Instead, we are using math score. Then if we use summary for math score, we'll see how it is printed compared to if we use another package that will be introducing now, which is the Broom package. The Broom package is going to make us have nice prints, especially when we want to print out models. It cleans it up for us. Okay, it says percent score not found. And that's because I have not added it here. Let me just go and copy that from this. Okay, right here. I'll simply copy this, then go this way. Table, okay. I'll add it somewhere here. Then add max score. So we have max score. I'm getting to this. So if I run this now, and I run this, we have our prints. We can't compare it to once we use something like this. Broom, oh, sorry, augments. Then we take the model name, math score model 1. We also have another one, which is glance, math score model 1. These are the right way to actually print regression results. Then lastly, we have tidy. But whatever is printed here, they do have their meaning and use case. It's not all the time that we print them all. So once I impute this, it gives us a result. I would not like this to be in my table, so I will not include this. Now I want to exclude this from my table, and what I'll do is I will use include false to not include it in the table. Then I can check glance too, and glance is going to show us the R square, the adjusted R squared, the sigma, and the statistics. White tidy is going to give us the expected results, which is all those intercept, the estimate, and standard error. Nicely printed. Now I'm going to render this because we've done a lot now. Control Shift K, or you click on the render button. And once this renders, we are going to see how different our document is. We'll see how nice it is to use these functions compared to using summary when we want to print regression outputs. Yeah. In the meantime, anybody with question? Anybody with a question? Okay. Now, yeah, this is the output. This is how summary prints out our output right here. So it's a bit, it prints out everything. But this is using the Broom functions with glance. This is glance from the Broom package. It returns the R squared and everything in a table. Once I add with a package like cable, with a function like cable, the print result is better. And this, if you submit it to any journal or a boss or something, they'll say you should make it more presentable. Of course, this should be more presentable, but this is just to show us some of the things we can do with Quarto and how easy it is for us to make corrections, especially when we are in a work where we need to make some changes. And here we see term estimate, standard error, nicely printed, and this is already having some things that is not well written. I think this is the sigma part, and the adjusted R. They are most up as one. All these can be edited to ensure that they are accommodated accordingly. And also, I can as well just change the table names, since this is returned as what? A table, not just any objects. I can set the names. I will now we use I will use 10. Okay, oh, this is the wrong place. Yeah, this side. This is the side with the issue, the problem. So we have R square. I can change that to RSQ. Then ADJ RSQ and SIG. Then SIG. Then starts. Then p-value. We also have df, log, what else? AIC, BIC. Okay, this is one big table. It's getting too big. It's a lot of things here. So I could just select maybe the first 1, 2, 3, 4, 5, 6, first 6 columns that I'm interested in. Then I delete the rest. But of course, this can always be made in a fashion that you want. You can choose to show everything if you want. So this has been made better. And once I render this, we have a good printout that is not like what we have before. Oftentimes, we are not interested in every output, AIC, BIC. AIC and BIC are ways to check how good our model compared to others. Yeah, and we have, this is deviance here, and this is also residuals, then nopes. Okay, let's see. Yeah, so this is a data print. So this is the main thing that we'll be covering in this masterclass, and it will be unfair to add more to what we've learned in the past 3 days, because we've moved from basic to actually intermediate level. And usually that takes about 2 to 3 months to get from basic to intermediate level. But I would salute you all for sticking around all through and from being here and also spend the time. So thank you. I don't know if you have any questions. If you'd like to learn more, we do have a bootcamp that is coming up around July. It's going to be for 4 months, and it promises to be packed. Yeah, we are going to do more of this, and we'll present our results. You also get your own personal portfolio. You have your own website as part of the bootcamp. It's part of the task that we'll be doing, and we'll do that using GitHub and GitHub pages. Yeah. So I don't know if anybody is having a question. And as I said, if you want to learn more, also, if you want to be well grounded in the basics, you can go to our YouTube page and you just watch our playlist on the fundamentals of R. It is quite thorough and in-depth. It is broken down to crucibles to ensure that even kids understand the concepts. Yeah. So this signals the end. This script will be made available as well as the Quarto document, so you can also experiment during your own time. I don't know if you have anyone with a question here, but for the meantime, I'm going to stop recording. Anybody with questions? Before I stop recording, anyone with question? Okay, let me stop recording.